Okay, so welcome back students. Namaskar, Adab, Sat Sri Akal. How are you? So now till now we have completed complete electrostatics. Yes, the massive topic of PU2 that we have already completed, that is electrostatics. We have seen all the derivations that are possible. We have seen that what kind of questions can be asked. Anyways, we'll have a questions series differently. But I've told you what are the topics that are important in complete theoretical manner. We have studied that topic. And now the extension part of that, the conductor part extension is because if I am talking about NCERT doesn't have any chapter differently for capacitance. But we are going to, because for competitive exams capacitance also becomes very important. That's why we are going to study capacitance as a complete separate chapter. Okay. So we will start capacitance in this lecture without any further delay. Let's begin. So, have you ever came to know about capacitance? Have you ever seen capacitance? You know the application of what is the application of capacitance? I can say yes. You have seen capacitance. Where? Can you tell me? You have seen fan. You would have listened about a term condenser. Condenser that is used in fans usually. If any student have listened about this term, they can understand what I am trying to say. Condenser is also a kind of capacitor. Okay. Capacitors is used in a lot of devices, day-to-day devices. We use always capacitor. Now go to your home and ask your parents. They will show you condenser, or otherwise you can go to some hardware shop. There you can have condenser. Okay. So what is this capacitor or condenser that I am saying? Capacitor is about a property of a body that can hold, that tells you about what is the capacity of that body to hold charge. What is the capacity of the body to hold charge? That property is called as capacitance, and that device is called as capacitor. Okay. So now there are different types of capacitors are present. Okay. But what we, and this is very small in size. It is not that I am talking about a very big thing. It is a very small in size, and in our syllabus, the majority of the discussion about capacitor is for parallel plate capacitor. Or obviously, we are going to see some spherical capacitors also. Cylindrical capacitors also. Parallel plate, obviously it is the main topic that we are going to discuss, but majority this complete chapter will be revolving only around what? Parallel plate capacitor. Okay. And lot of theories I've already mentioned, that these theories that are given, you have to remember most of those things if you are going for board exam. That will help you a lot in improving your marks, because I know that all of you are knowing the concepts, but in board exam only knowing the concept is not sufficient. You should know how to write that, how to write or how to explain the person who is checking your copies, that how you will attract that person. So there are lots of methods. You will draw a diagram, you will write the given things, you will write a statement about the given things. So these are some basic ways that if you are following, you will be having very good marks in your board exam. Likewise I have did for my board exams. Okay. So let's start for capacitance. Now what is capacitance? It is defined as, how capacitance is defined as, capacitance of a conductor can be defined as the amount of charge required to increase the potential of conductor by 1 volt. I will explain the first line after some time. It is defined as the charge that is given to a capacitor is directly proportional to the potential. What is the second statement? The charge is given to an isolated conductor, its potential increases. That's why we say that charge is directly proportional to potential. And when anything is proportional, when I remove this proportionality, I will have a constant, and that constant is written as C into V. And this proportionality constant is nothing but called as what? Capacitance. This proportionality constant is called as capacitance. That means if I will ask you what is capacitance, now you will say what? Q divided by V. This is the basic formula for capacitance. Okay. Here you can see it is capacity or capacitance of a conductor. So capacity is also defined as the ratio of charge stored to the potential at the surface of the conductor. Because capacitor can be defined as also as charge divided by voltage. These are other ways to explain the definition of capacitor. Now I will explain you the first statement. What is the first statement given? The capacitance of a conductor can be defined as amount of charge required to increase the potential of a conductor by 1 volt. Increase the potential of a conductor by 1 volt. So can I say, if I am putting 1 here, I can say charge will be equal to C. So what is C equals to? Can I say it is the amount of charge to increase the voltage by 1 volt. So you can understand from this relation very easily. And please remember, this is very important result. Q is equal to C into V, or C is equal to Q by V, in whatever form you want to remember this formula. Okay. These initially we are having some basic things only. Now, for if I am talking about a spherical body, spherical conductor, if I am talking, then what will be the capacitance? One more very important. What about the unit, sir? What will write the unit? Unit is, you can write what? In generally, what you can say, it is written as farad. Otherwise, coulomb by volt will be the unit, but it in standard terms we define in farad. Farad was a scientist. Okay, on his name it is defined. And in generally in this topic we always calculate, because farad is a very big quantity, we always take microfarad. We calculate capacitance in microfarads. Most of the cases we will be calculating capacitance in microfarad. Okay. Micro means 10 power minus 6. I hope that this will be clear to you. Now let's see what will be, how I will define capacitance for a spherical conductor. This is an interesting thing. This is a spherical conductor I have shown you. Okay. Conductor. Now I have told you about a lot about conductors in the last lecture of electrostatics. If you have not watched that video, please go and watch that video firstly, because capacitor is the extension part of conductor. So properties will also be same. I have told you what is the property of conductor. In conductor, charges are always coming on the over surface only. It is not spreaded into the complete volume. For non-conducting, it is spreaded into the complete volume, but for conducting surface, charges are always only at the surface. That means charge is all completely on the surface. Now, if someone is asking me, tell me how you will define capacitance. Firstly, tell me what is the potential on the surface. We know, we have derived the complete values. Potential can be written as kq divided by r. Now, if someone asks me, tell me capacitance, how I will define capacitance? I will write q divided by v. What I will write? Q divided by v. V is what? Potential. Q will be as it is. What is the potential at the surface? Kq divided by r. Can I say q cancel, and what is k? K is nothing but 1 by 4 pi epsilon naught. So can I say this result will be coming 4 pi epsilon naught into r. Here you can say, so capacitance for in air, if capacitance you are calculating in air, it will be equal to 4 pi epsilon naught r. And if you are taking it in a medium, tell me students what will happen. Here what is the term? Who is defining the medium? Epsilon naught, correct? Who is defining medium? Epsilon naught. Remember, force, Coulomb force in a medium, what I have told you, nothing will be changing. Just multiply a epsilon r term. Relative permittivity with epsilon naught, you will be getting your result, final result. So what you can do here, if capacitance you have to calculate in medium, let's suppose any medium is there, and they will give you always a relative permittivity also. With the epsilon naught, just multiply epsilon r, you will be getting your final result. So it is also written as capacitance in a medium, it is equal to epsilon r into C naught. C naught is what? Capacitance in the medium. That's it. Just multiply relative permittivity, you will be getting a result in the medium. Is it clear? Yes or no? Now some basic notes. These notes I have provided you for your board exam and for NEET exam also, so because sometimes statement based questions usually come, so you should be knowing the theoretical things very minutely. Capacitance determine the capacity of a system to hold electric charge. Firstly, I told you capacitance only depends on the dimensions of the conductor and the nature of the medium. But I'm saying it depends on the dimensions of the conductor and the medium, because C just you have taken for seen for this spherical conductor, it is equal to what? 4 pi epsilon naught into r. R is defining what? Dimension, and epsilon naught is defining what? The nature of the medium. These are the two things on which capacitor is dependent. Capacitance is independent of charge and voltage. Capacitance, here you can see, there is no term for charge, how much charge you have put on a spherical conductor or how much potential is there. No, because C is equal to 4 pi epsilon naught. Doesn't matter how much charge you are putting, how much potential is there. Capacitance will be remain same. It is fairly independent. SI unit of capacitance already I have told you. It is what? Farad. Okay. These are some basic points that you should remember. Now, what if I will ask you how much energy is stored by the capacitor? Because if charge is stored by the capacitor, obviously it will be carrying some energy along with it also. Because if charge is there, there will be some potential also. If there is some potential, there will be some potential energy as well. Correct? Everything is interlinked. And you remember what was the potential energy? Potential energy was defined as Q into delta V. correct? Or how we have described potential? Potential we have defined as U, that is potential, electrostatic potential energy divided by charge, and finally we have defined it as Q into delta V change in potential. This was defined for potential energy. So now if someone will ask me, tell me what will be the potential energy, what I will do? I will write potential energy is what, nothing but work done. Work done is converted into energy, so I will define it as dW is equal to V naught into dq. V naught into dq. Let's derive it on the next page. Here are some lots of theoretical terms that are given for you. So how I am going to define, please understand. I will write dW is equal to V naught into dq. Q into delta V, what I was telling you about. Now here some dq charge extra I have taken, that's why I have taken dq term, and potential is V naught. Now integrate both the sides. This time it will become, this side it will become work done, and work done is also nothing but change in potential energy, that will be equal to V naught will be coming out of integration. And exactly if I will ask you what you can write for V naught. V naught, and what is the relation for capacitance? You write it as Q divided by V. And if I will ask you to write V naught, how you will write? Q divided by C, correct? Now replace that V naught here, Q divided by C into dq integration. Now what will be the integration Q dq? It will be nothing but it is equal to, from initial charge, that is 0, to final charge, that is final charge is Q. That is from initial 0 to final, what it will become? It will be, the integration will be Q square. That means finally you will write what? Q square divided by 2 into C, that is what? Your potential energy or work done, whatever you want to call it. Q square by 2C. So further, how you can write this can also be written as, because Q is equal to, there are now other forms, in what form you want to remember, it's up to you. Q is equal to CV. So you can write what? C square V square divided by 2C. C and C will get cancelled. What you write? Half CV square. This is also an important formula. Same way, same formula, but just a different way to write the same formula. Is it clear? Any doubt? Easy? Okay. Now, types of capacitor. I have already told you there are lots of types of capacitor. Majorly, we are going to focus on parallel plate capacitor. There are some spherical capacitor. Already we have seen what is the capacitance of a spherical capacitor, 4 pi epsilon naught r. And then I will tell you in a question form about cylindrical capacitor also. One JEE advanced question was also coming on the cylindrical capacitor. We will be discussing on all these capacitors. So firstly, let's start from parallel plate capacitor. What is the capacitance of a parallel plate capacitor? Okay, let's understand. So how it does look? Parallel plate capacitor looks like this. If I will tell you, okay. Let's suppose these are two plates, okay, and these are two plates are conductor. Two conducting plates are there, and I have brought these two conductors close to each other. Okay, we brought these two conductors close to each other together, and this distance that is present between them, this will be the cross sectional area. This is the cross sectional area, and two will be identical. Here I have not taken an identical shape. These two are parallel plate capacitor, and the distance between them is very small. This system is called as parallel plate capacitor. This system is called as parallel plate capacitor. Now there may be one more question: why we have brought two conductors here? Why? So actually what happens when actually capacitance carry very low amount of charge. If you will be calculating that value, that will be coming in micro, okay, micro coulomb charges. So to increase the capacity of the body, to increase the capacity of the conductor, we bring one more. In isolated system, what happens? The capacitance of the body is very less. So to increase the capacitance, we bring two bodies, two isolated systems together, and then what happens? The capacity actually increases little. So that is more helpful for us. That's why we use capacitance as a pair, two conductors as a pair, and that here what we define as parallel plate capacitor. Okay. Parallel plate capacitor, this is one body. Now one body will be having a positive charge, one will be having negative charge, plus Q and minus Q. Okay. Due to that, what will happen? From positive higher potential to lower potential, electric field will be coming, correct? Now if I will ask you, tell me what will be the electric field, net electric field between them. Tell me what will be the net electric field between them. Can you tell me? You remember, these parallel plates will be behaving like an infinite sheet. Due to an infinite sheet, you remember what was the electric field that was coming? Exactly, sigma divided by 2 epsilon naught. And what was the direction? It was away from the body, correct? If it was a positive charge infinite sheet. So if I will ask you what will be the net electric field, let's take any point. I will say due to this positive plate, and what was the better part of that formula, that it is independent of the distance. Let's suppose if I am calculating here, what is the net electric field coming between them? This will be the electric field due to the positive, and I can say due to negative, naturally it is away from the body, but due to the sign of negative, I can say second electric field due to this negative plate will also be in the same direction. That means net electric field I can say 2 into E, because both are in the same direction. And due to one infinite sheet, what was the electric field that we have written? It was sigma divided by 2 epsilon naught. This 2 will be get cancelled, and I can say how much it will be coming. Net electric field between the parallel plate capacitor, it is equal to sigma by epsilon naught. As of now, just remember what is the electric field between a parallel plate capacitor. It is equal to sigma divided by epsilon naught. Now, and what is sigma? That is clear. That is also clear. Na? Sigma is what? Sigma is the charge distribution. Surface charge distribution is called as sigma. Now, second thing, if I will ask you, tell me what is potential. What will be defining the potential difference between the parallel plate? What is the relation for potential? Potential is written as E dot D. E dot D. What is the electric field that you just have written? Sigma by epsilon naught between them, and the distance between the plates is D. So this will be what? Your potential. Correct? Till now it is clear. Now that we will derive what will be the capacitance. Now we will derive what will be the capacitance, and how we will write capacitance. Capacitance is written as Q divided by V. Q divided by V. Q divided by V. What V you can write? Sigma D into epsilon naught. Correct? Now, if I will ask you how I will write sigma, sigma is what? Surface charge density, that is charge divided by area. This cross sectional area that is given here is, this is A, nothing but. So I will define sigma is equal to Q divided by A, and here it is already Q epsilon naught D. What I can say here, that Q will get cancelled, and finally the capacitance that will be coming, that is equal to A epsilon naught by D. For a parallel plate capacitor, it is a very standard formula that you have to remember. C is equal to A epsilon naught by D. This is the formula that you have to remember. It is the most usually formula, and it is a very general formula also in this topic, capacitance. Okay. Now, if I will ask you about what will be the work done, again it will be the same thing, same formula. This time I have connected it by a battery of voltage V. The energy stored in the parallel plate capacitor is given by the work done by an external agent, which in this case is a battery. Battery is the external agent to raise the charge to Q, and then the potential to V. Initially it was at zero charge, it doesn't have any charge. What will be the work done in charging it from 0 to Q? Thus it will be stored as an electric potential of the system. At some instant the charge on the potential of the capacitance on the capacitor is Q, V naught and C. These are the final values that are given. The small work done in raising the capacitance by a dq amount is given by, how you will write the work done? You will write TW is equal to V naught into Q. Already just same as the last derivation that I did, it is going to be the same one. dW is equal to V naught into Q. Integration from what to what charge you are going to integrate it? You are going to integrate it from 0. Initially, how much was the charge? 0. Finally, what is going to be the charge? Q. Now, how you write V naught? V naught will be written as Q divided by C. Correct? V naught will be written as Q divided by C into dq. Integration is from 0 to Q. Integration will be giving you Q square by 2, and C is here. Limits will be from 0 to Q. Finally, the final result will be coming, that is will be equal to Q square by 2C. So always remember, work done by a battery will be is equal to Q square divided by 2C. Okay. Now, energy stored in a capacitor. Now, same formula, but different forms are there. It is very beautifully explained by this table. All these forms have to be remembered. it will always should be in your mind. Firstly, what we have written, q square by 2c, and then we can substitute q is equal to c into v. Substitute q is equal to c into v. It will become c square v square divided by 2c. C cancel, but you can write half cv square. Here you can see the same formula is equals to half cv square. Now c can also be substituted. C can be written as q into v. This is a relation in q and c. This is a relation in c and v, and this is a relation in q and v. So all these three relations should be remembered, that at whatever time it will be required, you will be using according to the situation. Replace c is equal to q into v. What is that? Q by v into v square by 2. This v will be get cancelled, half into q into v. This will be the third form of the same formula. Now it doesn't matter which formula. According to the situation, you have to apply the formulas. Okay, formulas are there for you. I hope that this table will be very much clear to you. Okay. Now, how you will define energy density? Energy density in the last case, in the last topic of electrostatic, I have explained. Here also energy density will be same. Okay. Let's see how you can write. What is the energy you write here? U is equal to half CV square, correct? And what is C you define? C is equal to A epsilon naught by D. And what is V? V is equal to E into D. If I am talking about in relation with the electric field that is generated here. Now put the potential energy here, half into C, A square epsilon naught square divided by D square into half epsilon half C. This is C. Sorry, C have to not be squared. C will be written as it is. Correct, right. Half C, that is A epsilon naught by D, into V square, that is E square D square. D simply get cancel out. What will be remaining part? It will be half epsilon naught E square into A into D. Now what is area into D or area into length? It is always written as volume. It is always written as volume. That means in next step what you will write, potential energy divided by volume. It is equal to nothing but half epsilon naught E square. This means energy density is given as half epsilon naught E square. Energy density for a capacitor, it is always given as half epsilon naught E square. Is it clear? Don't worry, we will be having a questions in the different series. Okay, there you will see a lot of practical examples on this. We will discuss about what kind of questions are coming. As of now, for board perspective, remember all these things in step by step. Nothing, not a single step should be left from here. Okay. Now, if I am talking about what are the forces that will be acting on the plates. If two plates are there, if there is some electric field between them, obviously there will be some force also acting on the plates, correct? Force will be acting same on both the plates. Because you know that if one body is positive charge, one body is negative charge, that means obviously there is some Coulomb force, okay? That means if I ask you how you will define force, let's suppose you want to write force on this body 2 due to body 1. What you will say? Force is defined as Q into E. Force is defined as Q into E. And how you are writing? You are writing force on 2 due to 1. How you will write? You will write the charge, that is Q, and then you will write the electric field that is felt by, what is the electric field will be feeling by this surface due to this one. I can say what will be the electric field? It is equal to sigma divided by 2 epsilon naught, that is coming due to body 1, correct? So you will write sigma divided by 2 epsilon naught. Then now what you can define for sigma? Sigma is nothing but what? Sigma is charge divided by area, that means it will become Q square divided by 2A epsilon naught. Here you can see force is equal to Q square divided by 2 epsilon naught, a good formula that you can remember. Simply I have written how, because always force is defined as Q into, force is always defined as Q into E, charge into electric field that is present or that is felt by the body A, or same way you can write for body B also, just the directions will be reversed, magnitude wise it will be same. Okay. Now for a spherical capacitor, if two capacitors are there, now because we have seen for parallel plate, because that we have kept two parallel plate capacitors simultaneously to increase the capacitance. Now we can keep also for spherical bodies also, correct? Now for spherical body, if I am keeping two spherical body, how I will be calculating the potential, how I will be calculating the capacitance, correct? So see, the inner cell is connected to the positive terminal of the battery, and the outer cell is connected to the negative terminal of the battery. Inner cell is connected to a positive terminal, and the outer cell is connected to the negative terminal. Okay. So how we define capacitance? It is defined as Q divided by delta V. Now this is, what is this delta V? This is a potential difference between the two surfaces. That means I will write for V1 minus V2. Now if I will ask you to write potential on body 1, potential at body 1, this is the first surface, this is the second surface. Okay. And the radius, if it is not clearly visible, this is radius A, this is radius B. How I will be writing potential at surface 1? Potential at surface 1, tell me. I will write potential due to surface 1, it is what kind of point? Inside point, plus potential due to surface 2, it is what kind of point? Again it is an inside point, correct? How you will write V1? V1 can be written as what you will write V1 as K Q1 divided by KQ1 divided by simply directly write now. Directly write Q divided by, what you will write potential due to on surface 1, what you will write K Q1 divided by, what is the radius of that body? A, minus, what is the potential at surface B? You will say minus, and due to surface, this is the potential due to surface 1. Now what you will write potential due to surface 2? It will be K Q2 divided by B, because there is a negative charge, that's why I have written, and the charges are given Q and Q only, or charges are also different. Let me check once. Charges are given same, only the magnitude wise it is different. Let's it got deleted. Let's write it again. At V1, write the potential properly, because I have told you it is defined as Q divided by V1 minus V2, difference of the potentials. How you write V1? V1 due to surface 1, it is what kind of point? Inside point, minus potential due to surface 2, that is, for that also it is a kind of inside point. Due to this, what you will write? K Q1 divided by R1 minus K Q2 divided by R2, because both are inside point, and for inside point potentials are always constant, KQ divided by the radius. Now if we will ask you to define V2, how you will define? You will write K Q1 divided by R2 minus of, because for 1 it is again, it is an outside point, KQ2 divided by R2, and for this you will write KQ2 divided by R2, again it is a kind of inside point. Now if I have to define the capacitance, how I am going to define? With the radiuses R1 and R2 are A and B respectively, so I have to write here V1 minus V2, that's right here. C is equal to Q divided by V1 minus of V2. How it will be written? V1, it will be written as K Q divided by A. Remember what was the potential that we have written? K Q divided by B minus of V1, that is completely written here. What will write? K Q divided by B minus of K Q divided by B. Okay. Now what are the things that can be cancelled out from here? Solve it. K minus of here is there, and this is plus. Now what will be left? K Q divided by K Q by A minus of K Q by B. Now take K Q as common, and this K will be going upside, and this Q simply get cancelled out. 4 pi epsilon naught, this when this is going in upside direction, and here will be left what? this will be B minus A, and here it will be multiplied A into B. This is the capacitance due to two concentric shells. It is a very standard result also. So if you want to remember for NEET students and for board students, I will tell you board students have to remember this complete derivation also. But for NEET students, I will tell you that remember the result so that quickly you can solve the questions as well. Correct? Is it clear? And for writing potentials, there was a question I have taken in the last lecture of the last question that I have taken, the last part of electrostatic, that was exactly the same question. I have asked you to at some points, 3 points I have taken there, A, B, C, and I have told you how to write potential at every single point. Same thing you have to do here, just simply do C is equal to Q divided by delta V and write the potentials properly. Simply it will get cancelled from here, and capacitance will be equal to 4 pi epsilon naught into AB divided by A minus B minus A. Correct? Is it clear? Any doubt? Now see, next concept is charge distribution. How charge is distributed or redistribution of charges. Whenever two bodies are connected, always remember in the first lecture, very first lecture of capacitance, I have told you that charge is always conserved. Charge cannot be created, cannot be destroyed. So in an isolated system, charge is always conserved. That is the concept that is based here. When two charged conductors are joined together through a conducting wire, charge begins to flow from one conductor to another conductor from higher to lower potential. Until when it will be traveling? Till it will not be till infinite that it is traveling. Let's suppose a body is here having charge Q1. Here is a body having charge Q2, capacitance C2, and it is at a potential V2. Here the capacitance is C1 and the potential is V1. And now let's suppose I have connected both of these bodies. I have connected. So now what will happen? Charge will be start traveling from higher potential to lower potential. If I am saying that if in case V1 is at higher potential, what will happen? Charges will be transferring from V1 to V2. Now till what time it will be traveling? There will be some restriction. It is not like that for infinite time. Now it is traveling. So it will be traveling till both of them have reached to a common potential. Let's suppose that common potential is V, and at that time it will have some Q1 dash charge and it will have some Q2 dash charge. Capacitance will remain same because capacitance is not dependent on the potential and the charge. Already I have told you. Okay, because capacitance is an independent quantity. This is the capacity of a capacitor. So and now interesting thing will be how we will be calculating Q1, how we will be calculating this common potential that will be here. You can see that it has been connected and the final parameters are like this. So now we will be calculating all the things. What is the common potential? What will be the final charge by writing some equations. What I can write an equation if I will ask you here, a very basic thing from the concept that I have told you. I can simply write what was the total, if I am taking this as any isolated system, what is the total initial charge? Q initial should be written as Q final. So what is the initial charge that we have written? We have written simply Q1 plus Q2. So now if I will ask you what is the final charge, you can write, you will write Q1 dash plus Q2 dash. Q1 dash plus Q2 dash. Okay. Let's see how we will be deriving. Come to the next one. Firstly, let's write what is the common potential. What will be the common potential? I have told you to write charge conservation, and how we have written just the same equation. Q1 plus Q2 is equal to Q1 dash plus Q2 dash. Okay, and Q can be written as C into V. So how I will write this? Q1 can be written as C1 into V1 plus Q2 can be written as C2 into V2. What I can write for Q1 dash and Q2 dash, if they are at the same common potential, correct? That means what I will write? I will write this as C1 into V plus C2 into V. But that means can you say I will take a V common from here and it will be what? C1 plus C2, and here it will be what? C1 V1 plus C2 V2. That means what I can write, the common potential that you will be getting, common potential will be written as simply C1 V1 plus C2 V2 divided by C1 plus C2. This is the common potential, and I will say that if you can remember this result also, because this is also a standard result. It's your choice. If you want to remember, you can easily remember. It is not a complicated formula. Simply do C1 V1 plus C2 V2 divided by C1 plus C2. Okay. This is the common potential. Still our job is not done. We have to calculate what is the total charge also, Q1 and Q2 also. How I will be writing? Now see, what I can say, this is the first thing that will be valid. Q1 plus Q2 is the total initial charge and it is equal to final charge, and let's suppose the charges are equals to, total charge is equal to Q, okay, because that is not going to change. So how I will be calculating the final charges Q1 dash and Q2 dash, that is what I am interested in. So how I can write Q1? Q1 can be written as, let's write everything, C1 into V1, correct? Q2 can be written as what? C2 into V2. Q2 can be written as C2 into V2. Now if I'll ask you to write the final potential, how you write? Q1 dash is equal to, Q1 dash is equals to, you will write C1 into V, that is the common potential, and Q2 dash you will write C2 into V. Any doubt? Any doubt in this? Correct now? Now take the ratio for this one, Q1 dash and Q2 dash. What you will write the ratio as? You will write C1 divided by C2, because V will be simply get cancelled out. And what you can write for C1 and C2, because these are spherical surfaces, for what is the capacitance of a spherical body, you know already very well that it is equal to 4 pi epsilon naught R1 divided by 4 pi epsilon naught R2, correct? That means, can you say that it is nothing but equal to R1 by R2, because 4 pi epsilon naught, 4 pi epsilon naught will be simply get cancel out, correct? Now what you do one thing, do addition of 1 here on this side and do addition of 1 on this side. There is no change I am doing. I am adding both the sides, plus 1 plus 1. That means here what you will do, you will write Q1 dash plus Q2 dash divided by Q2 dash, that is equals to R1 plus R2 divided by R2, correct? From here what I can say, this is total this is in total is what? This is the total charge. That means what I can say, because Q1 dash plus Q2 dash is the total charge, and I want to calculate what is Q2 dash. That means Q2 dash, I can write this R2 will be going here, that is the total charge into R2 divided by R1 plus R2. This is the total charge that will be present on the capacitor 2. Q2 is equal to Q into R2 divided by R1 plus R2. Same way now you can calculate for Q1 as well, because the ratio is already given to you, that is equals to R1 by R2. Same way you can write for Q1 dash also. So these are the final charges that also. Now it's up to you. For JEE students, I will say that for board exam students, again I will say that you have to remember the complete derivation. Everything you have to understand from basics. For NEET students, remember the direct result, how you will be writing. Let's suppose any question can be asked. Let's suppose you are connecting two bodies, what will be the final charges, what will be the common potential. These kind of questions can be very oftenly asked. And I will say that remember the final charge also. For JEE students also, they can also remember. It is nothing not complicated, this much of formula you should be knowing. So it will increase the efficiency of your question solving, nothing extra. Okay. Now if someone is asking you, tell me what will be the energy loss in this traveling, what happens actually in the system when you connect two bodies, when these electrons are traveling, there is some collisions also between the electrons, and due to those collisions some energy is lost also. And what is that energy loss? That is what we want to calculate. That energy loss is written as, simply it is written as U initial, that was the initial energy, minus final energy. Of course, this is the basic way how I will get. Initially I had 10 apples, okay, finally I am having 5 apples. How much apples I have lost? 5. How I have calculated? I just subtracted. Let's suppose initially my energy was 20 joules. Finally, after traveling all these charges and sharing of charges, when it was completed, I have only energy 5 joules. How, that means how much energy I have lost? Can I say easily? I can say that I have lost 15 joules of energy. Is it clear? So I will write U initial minus U final. Now tell me how you will write U initial. That is the one thing. You will write U initial. Let's write U initial. You will write half C1 V1 square plus half C2 V2 square. This is what I can write for initial. And how I am going to write the final one? I will write the final potential. I will write half C1 V square plus half C2 V square. Now take common, half in bracket, what will be left? C1 plus C2 into V square. Now what is V square? Final common potential is what? C1 V1 plus C2 V2 divided by C1 plus C2. Correct? This is what I have asked you to remember also, and there is a complete square on this. Now if we will be solving this C1 plus C2, and this square of this downside will be cancelled out, and the final potential that you can write, that is equal to half C1 V1 plus C2 V2 whole square divided by C1 plus C2. This is the final potential that you can write. Now and no need to remember this result. Now very easily you can write this result. There is nothing like such that. And now if the question is asking you, and always this initial energy will be greater than the final energy, because some energy loss is happening, that means obviously always the initial energy will be greater than the final energy. Fine. Now how you will calculate the loss of energy? Simply subtract both these quantities, u initial, u final, both are the things that you already know. Okay. Now V1 minus V2 is always positive, C1 into C2 is always positive. That means of course the change will always be positive, u initial minus u final, and it is very obvious guys here. If you are losing some energy, that means initially you had some higher energy and finally you are having some lower energy, then only you can say na, that you are losing some energy. Otherwise what you will say? I am gaining some energy, but here what I am saying, losing energy. Okay. And when you will be subtracting, this kind of result will be coming V1 minus V2 whole square C1 C2 divided by 2 C1 plus C2. Now it's I am leaving up to you. If you want to remember this result, very good. If you don't want to remember this result, then also there is no problem. I have told you to how to write from the complete basics. That is what important. You should be knowing, if you are stuck into the exam, you shouldn't be blank. That okay, now what I will do? What is the next step? How I will be tackling the thing? This shouldn't be the case that should be generated in your exam. Okay, so that's why you should be remembering the result also. It's completely up to you. Okay. Now here is a basic question, and with this question we will be ending this session. So let's firstly try you by yourself. What is the question given? What is the question given? Two conducting spherical bodies of capacitance C1, that is 10 microfarad. C1 is given as 10 farad it is given, and C2 is given as 100 farad. Okay, are given a charge 100 coulomb. Okay, both are given 100 coulomb. They are linked together with a conducting wire. Finally they are getting linked with each other. The common voltage attained as well as loss in energy in transfer. You have to tell me what will be the common potential that they will be achieving, and what is the energy loss that is going to be happening. So what we will do, very basic. Let's now whatever we have derived, now let's try to write it in the form of numericals. First tell me, if this is the case, what I can write for V1, what will be the V1 initial potential? I can write simply it as, because Q is equal to C into V, that means V can be written as Q divided by C. What is Q? 100. What is C? That is 10. V1 will be equal to 10 volt. What about V2? V2 can be written as 100 divided by 100, that is equal to 1 volt. First, these two things are clear, and what we have to calculate? We have to calculate the common voltage first step, and then the loss in energy. Firstly, let's calculate what is the common voltage. Should I write it from initial, or I guess that you remember the result, final result. It was very easy. Common potential you can write C1 V1 plus C2 V2 divided by C1 plus C2. Now put the values. C1 V1. C1 is 10. V1 is 10 plus C2 V2, and I can say, yeah, initially charges are given. It is nothing but what? Initial charges. So I am also just unnecessarily writing it. C1 plus C2 is the thing that you can write. It will be 110. That means what is the result? 200 by 110. Cancel. 200 by 11 volt. Any option that is coming? 20 by 11 volt. 20 by 11 volt. Option B. Option B will be the correct answer. Is it clear? But anyways, we will calculate the, don't worry, we will be calculating the final result also, that what will be the loss in energy that we are getting. For that, what we will do, let's move to the next page. 20 by 11, remember this result. Okay, shit, it is already done. Let's try to write the initial energy. Initial energy, how you will write? There is a final result or the direct formula also. If you want to calculate from here, you can calculate. There is no problem. But we will be going step by step. How you will be writing initial energy? Half C1 V1 square plus half C2 V2 square. Correct. Now I think that we should solve on the last page only, because there was more space and the values are also here present. Correct. Here we should solve. Initial first part was clear. You all of you have seen how we are getting the energy. If anyone have missed it, you can take go for 10 20 seconds back and you will get the result. V1 can be written as Q divided by C. That means here it was 10 volt and V2 was equals to 1 volt. Let's write the initial energy. Otherwise formula is also there, completely up to you. Half C1 V1 square plus half C2 V2 square. Always try to have the habit of writing the formulas also. There is no harm in writing the formulas. C1 is how much? 100. C1 is given as 10. Sorry, it is given as 10. It is given as 100. It is given as 10 into V1 square. V1 square is nothing but 100 plus half into C2. C2 is nothing but 100 into V2 square, that is 1. How much it will become? It is 10 power 3 by 2, and here also it is nothing but equals to 100. Correct now? 10 power 2 only. C1 is 10. Correct. Divided by 2. That means how much net it will become? This is 1000. That means I can say this is nothing but equal to 1100 divided by 2. That means my initial energy was 550 joules. Initial energy was 550 joules. Now let's try to calculate the final energy. Final energy can be calculated as half C1 plus C2 into V square, half C1 C2. C1 is 10, C2 is 100, that means 110 C1 plus C2, and final common potential was coming equals to, we have calculated 20 by 11. 20 by 11. This 11 will cancel out, this will be coming as 10. This will be coming as 10 and this will be also as 10, that means near about it will be how much? It will be coming equals to 100 joules. It is coming as 100 joules. Somewhere calculation mistake we have did. Values are given 10. This is 100. This is 110. Half C V square. Okay, sorry. Correct now. Here V square is there. That means you have to multiply 20 by 11 as well. This is not 100. That is what. That's why answer was not matching also. There is a term 20 by 11 C V square. No? Now what is left? Here it is get cancelled 10. Here it is get cancelled. That will be 10. It is nothing but net, if I will add 20 into 100 divided by 11. Now what you will do, because they are not going to be directly subtracted from here, what is the nearest possible answer? That is what you have to quote. Anything that you can do, tell me what will be the thing that you will be writing. 11 divided by 20. 11 divided by 20. 11 9 0 8 1.8 somewhere will be coming. 88 to 1.8 and then multiply 1.8 by 100. What will be there? Nearly 180 joules will be coming finally. If final is nearly 180 and initially is 550, what you will say as loss will be written as 550 minus approximately 180 joules. Tell me what will be the subtraction. 0, 15 into 8, that is 7. Then there is 4 minus 1, 370. Which option is coming nearly equal? Correct. Anyways, answer we have already predicted, but our second part of the answer is also coming. It is because I have not calculated exactly. I have calculated this as 1.1, and this will be sufficient for giving you the fair idea about the answer that you will be getting. That is equal to 368 joules. Okay, this much of energy is lost. Simple calculation. Initially I have how much energy? 550. Finally I have got how much energy? 180 joules, and just subtract that, it will give you what idea about the loss of the energy. Is it clear? Have you enjoyed the capacitance first lecture? It is a very easy topic. Don't take it as a very headache topic. Okay, nothing serious. One more lecture will be, I guess, sufficient. We will be calculating this, completing this chapter. So until next time, keep learning, keep growing with tapasya, and they go, and then they go, when nama tapasya.